I'll spend some time to talk about default values, their value, and their limitation. And then at the end, I'll give you an interesting story that happened, a regression in Postgres 14 that is caused by one of those default values. You see, when you build an API or an application, and it's pretty, it's a newborn application. You don't really know much about the app, so you do your best guesses. You expose limited number of configuration or parameters if that's an API, and you say, I think that's what the users want. And you build it and you ship it. And then later you understand, as the software is being used in the wild, either because of direct user requirements, says, hey, can you allow me to change this thing? Or can you allow me to change that thing? Or because of understanding of certain performance bottlenecks, that you say, you know what, this parameter really need to be exposed so that we give the users the choice to do whatever they want. And the moment, regardless of the reason of why did you expose that parameter or configuration, because that's how you expose it, either as a configuration or as a parameter. And the moment you do that, you're faced with a dilemma, because that extra configuration, you can force users, one choice is, you can force users to explicitly set that parameter or configuration. Now you have to set it. Guess what? All the users will start to freak out, because wait a minute, in the old release, it used to work just fine. Now it's telling me I have to set this thing. And most 95% of the users will freak out. And will say, I don't know what to do. I don't know what to set. Some users will set it to some value and then move on. So you're breaking things. And to engineers, this is scary. We don't like to break things, essentially. And we don't really like to break users. It's scary to break users by adding an extra parameter. So we do the latter, which is to set a default value for this new configuration based on an old existing behavior. So all right, in this existing behavior, this configuration would have been X, and we set that default value X. And mostly this works, right? Because you don't really change that anything, nothing changed. You just exposed something that is the default value anyway. It was hard-coded at some point and you exposed it. But then you gave a user a choice to change it, which is powerful. Okay? And you can see this pattern, right? Exposing configuration that didn't exist before. Take Postgres, for example. If you go to the Postgres documentation page, and in the editing I'll try to add that, you will see in the first release 8.3, that's as far as we can go, right? You'll see probably in the I don't know, sort of the wall configuration, you'll probably see 2 parameters. But then jump into the 16 and you'll see pages of just scrolling of the configuration. So that's a natural evolution pattern. We evolve this way, right? And we set default values for what we think is the best. And the danger happen when these default values change. And that's what happened in Postgres 14. Right? For the longest time, vacuum. If you don't know, vacuum is a utility, is a post-process utility that runs in Postgres, and it cleans up dead tuples in the database, as long as they are no longer needed by older transactions. They no longer satisfy the multi-version concurrency control. So if that is the case, they say, all right, this is safe to remove. Because you see, if you insert a row, if you delete a row, or you update a row in Postgres, you always get a new tuple for that row. So a row can have multiple tuples representing its current state. And you can read the old things if you would like to. Like if I'm a transaction that I started in a certain moment, and then another transaction started after me and deleted that row and committed, as long as I'm pinned to that snapshot, to that moment, I should still see that deleted row. And that's how tuples and multi-version concurrency. I talk about all that in my database course. Check it out. Databases.win. Made it short so people can remember it. And now, what happened is, and so that's a vacuum, how vacuum works. So vacuum, you specify a table, and then it vacuums the entire table by scanning the entire table. But it also does so many other things. Update the visibility map, freezes things to avoid the transaction wraparound, so much thing. But also, optionally, well, I say optionally, but it also finds all the indexes or indices, if you're from the UK, and vacuums those two, because you see the tuples, pointers, also live in the index, so you need to clean those up. But the maintainers of Postgres found out that by default, until Postgres 14, vacuum always cleaned up all the indexes when you clean up their corresponding table. And they found out that this slows down the vacuum process at an expense of basically additional cost to clean up those indexes for little gain. Cleaning the indexes in certain cases, there is some heuristic they use. They all right, if the index has only 2 tuples, but the problem is, like, I have to scan the entire index to find that dang 2 tuples, and I took the hit to scan the entire index for nothing. So they just like, it's all right, I'm gonna do a conservative approach, right? So that's the old behavior. Always clean up the indexes. But then in Postgres 14, they changed that. They made a configuration and they exposed it and called it index cleanup. I think that configuration was always there, maybe introduced in Postgres 9 or 10, but the default value was on. It's like, hey, always clean up the indexes. But then in Postgres 14, it was changed to a value called auto, which means, let me decide as a Postgres database that I think you're good. I think I'm going to skip cleaning up the index. And this created a performance regression. And Mark Callaghan, he's basically the performance guru when it comes to databases. He found that. So he says, like, hey, something is happening in Postgres 14. I have no idea why. In Postgres 13, fast. Postgres 13, in my regression, my runs, it gets slower. What happened? What would happen is Postgres 14, the default has changed to auto, which resulted in indexes being extra bloated because vacuum didn't clean it up. I'm going to repeat that because the car passed. In Postgres 14, the index cleanup option was changed to auto, which resulted in indexes being extra bloated, which means, what does bloat mean? You need to do more IOs. More IOs work more slowdowns. Very, very, very interesting. But of course, he didn't realize that a default value has changed. It's hard to document all that stuff. Probably it is, right? And you can go through the document and see what configuration. But nobody that I know, experts, know every single configuration of every single database. It's impossible to know. So after talking to the Postgres maintainers, he had a dialogue and documented in his blog. And he said, hey, actually nothing changed. We just changed the default values from on to auto. So he flipped that in his configuration to on the old default, and guess what? Everything went fine. So that's what I want to talk about. Default values are amazing. They are, developer ergonomic. I butchered that word, but you know what I mean. But watch out, because every time we hide something, we get bit eventually. And that's what's called leaky abstraction. The abstraction here was the index cleanup, and it was hidden. What was that? It was hidden from us. So you have to find the sweet spot at the end of the day between having default values or having explicit values. And it's, I don't think there is an answer for this. But what do you guys think about this? Let's see you in the next one.